This is the third lecture of the second week, and here we're going to talk about the t-test. So after fitting a regression line, you want to know whether the coefficient beta 1 and beta 0 that you estimated is statistically significant or not. What we mean by statistically significant here is that the betas that we estimated are not equal to 0. In order to test this, we need to do a hypothesis testing, which was covered in week 1 lecture. In order to do a hypothesis testing, first we need to have null hypothesis and alternative hypothesis. So for the null hypothesis, we say our slope, or beta 1, is equal to 0, or not statistically significant. Versus the alternative hypothesis of beta 1 not equaling 0, or that it is statistically significant. The test statistics for this test is a t-test, and it is beta hat 1, which is what we estimate, minus what we predict what the null hypothesis is. So in this case, beta 1 is equal to 0, and divide that by standard deviation of beta hat 1. So when we're carrying out a hypothesis test to evaluate slope term, we're basically trying to test whether the beta 1 is equal to 0 or beta 1 is not equal to 0. In other words, if beta 1 is equal to 0, that means that the slope is 0. In other words, regardless of the x value, y value doesn't really change. When we're testing whether beta 1 is not equal to 0, we're saying that there is some sort of a slope, whether it's positive or negative. And what this is saying is that x value changes the y value. So depending on what the x value is, y value will be different. So there is some sort of relationship between x and y. So let's look at the data output again. Here, now we want to test if our coefficient is statistically significant or not. So in order to test that, we need to set up a null hypothesis of beta 1 equaling 0. In our case, beta 1 is student to teacher ratio versus alternative hypothesis that the student teacher ratio is not equal to 0. Then we need to calculate the test statistics. So using this formula, our beta hat 1, which is the estimated coefficient of STR, is given in this data output, negative 2.28, minus the null STR, which is in our case, we're testing if STR or student-teacher ratio is equal to 0, divided by the standard error of our estimated coefficient beta hat 1, which is also given in data output, 0.52. So when you calculate this test statistics, you get negative 4.39, which data also outputs in the output. When you have this test statistics, you need to compare it to critical value. So in the hypothesis testing, you can either use the critical value method or p-value method. First, using the critical value method, say we want significance level alpha at 5%. The critical value is 1.96, and you can get this either through using the table in the back of your textbook or from the website. You know that the test statistics that you calculated, negative 4.39, the absolute value is greater than 1.96. So we reject the null of beta 1 equaling 0 at 5% significance level. Another method is a p-value method. So in p-value method, you reject the null if your p-value is smaller than the significance level. So if you set the significance level of 5%, the p-value that are given here in data output is 0.000. So 0 is less than 0.05, So we reject the null and conclude that STR is statistically significant or STR is not equal to 0. As you can see, p-value method is a lot easier when using data output than t-statistics because to use the critical value method, you need to know the critical value. But in order to use the p-value method, you only need to set the significance level. So when you're using this data to do your regression, I recommend using p-value method. You can also use data to easily construct the confidence interval. So going back to week 1's lecture, in order to construct the 95% confidence interval for beta 1 or student to teacher ratio, the formula would be the estimated coefficient plus or minus 1.96 times the standard error of the estimated coefficient. These numbers are all given in this data output. So estimated coefficient is negative 2.28 plus or minus 1.96 times the standard error 0.52. And you can get this confidence interval of 95%. You notice that this is also given in data output, so you don't need to calculate this by hand. Also notice that negative 3.3 to negative 1.26 does not include 0, meaning that the hypothesis beta 1 is equal to 0, it can be rejected at 5% level. So confidence interval means that 95% of the times, this confidence interval includes the true mean, but this confidence interval right now doesn't include 0, so it means that beta 1 must be not equal to 0. Or beta 1 equaling 0 is not a true mean.